Think about how we predict the future. How do city planners know where to build a new train line? Or how do economists guess how a new tax will affect everyone? They build models of human choice. But here's the thing, building the right model has always been more of an art than a science. Well, today, we're going to talk about an AI framework called Delphos that's actually learning to master that art.
Okay, so here's how we're going to break this down. First, we need to understand the massive, almost impossible puzzle that researchers are up against. Then, we'll look at the old way of doing things, the kind of rigid, fixed-rule automation people used to use. After that, we'll dive into how Delphos learns, how it actually plays the game of modeling, and what kind of amazing results it finds. And finally, we'll talk about why this is such a huge deal for the future of science.
All right, let's jump right in with the core problem, the big challenge that Delphos was designed to solve. It's a puzzle that has stumped researchers for decades, and it all boils down to understanding the choices we humans make every single day.
So this is the heart of the matter, right? Why do you choose one brand of coffee over another? Or one route to work instead of a different one? We want to understand the why behind all those little decisions. But trying to create a mathematical formula that captures that, well, that is way easier said than done.
The best way to think about it is like a jigsaw puzzle, but one with an absolutely insane number of pieces. Every little factor you can think of, cost, time, brand loyalty, convenience, that's a puzzle piece. Every single way those pieces could possibly connect and influence each other, that's another piece. For years, the only way to solve this was manually, relying on a researcher's gut feeling and experience.
Now, the fancy name for these puzzles is discrete choice models. These are the mathematical tools that are the absolute bedrock for predicting behavior in fields like transportation, economics, and public policy. Get the model right and you have a powerful crystal ball. But get it wrong, and your predictions can be biased or sometimes just completely off the mark.
And to really wrap your head around the scale of this puzzle, just look at this number. For one single dataset, a well-known study about transportation choices in Switzerland, there are over 88 million possible models you could build. Trying to test every single one is, well, it's not just hard, it's literally impossible. You couldn't check every combination in 100 lifetimes.
So, faced with this impossible number, how did we even try to solve this in the past? Well, to deal with the insane complexity, researchers naturally turned to automation to help them search for good models. The old tools were called meta-heuristics, and they basically treated the problem like a static math challenge. They used a fixed set of rules to just search and search for the best answer. But they had this one giant critical flaw. They didn't learn. They had no memory. They'd apply the same dumb strategies over and over, never remembering what worked, or, just as important, what didn't work. This meant they wasted tons of time exploring dead ends again and again.
So the old way was hitting a wall, and this is where Delphos changes everything. The idea was totally different, and honestly, pretty revolutionary. The creators asked, what if, instead of just automating a dumb search, we could actually teach an AI to learn the art of scientific modeling itself?
And this chart just lays out the difference so perfectly. On one side, you've got the old automation, just following a fixed blueprint, totally inflexible. But then you have Delphos, which learns from trial and error. It adapts its strategy based on what works. It actually builds experience over time. It sees modeling not as a single task, but as a dynamic process of learning. Kind of like how a human researcher does, but with the ability to run thousands of experiments at superhuman speed.
This quote from the original paper just hits the nail on the head. The real breakthrough here isn't just better code, it's a complete reframing of the problem. Finding a great model isn't about finding one right answer in a giant haystack. It's about learning a strategy to navigate that haystack intelligently.
So how does Delphos actually do this learning? Well, it uses a super powerful technique from AI called reinforcement learning. You've probably heard of it. It's the exact same approach that AIs like AlphaGo used to become the undisputed champion of the ancient and incredibly complex game of Go.
The idea behind reinforcement learning is actually pretty simple. An AI agent learns by doing. It tries out an action in its environment, and then based on the result, it gets either a reward or a penalty. Over millions and millions of tries, it starts to figure out which actions lead to the biggest rewards. So just like AlphaGo learned what moves win the game, Delphos is learning what modeling decisions create the best science.
The whole thing works in this continuous loop. First, Delphos takes an action. It decides to do something, like add travel cost as a factor in its model. Then, the environment does the estimation. It tests that new model out. Third, Delphos gets a reward, a score based on its performance, its simplicity, and even if it makes common sense. And finally, the update. Its brain, which is a neural network, gets tweaked based on that reward, making it a little bit smarter. It does this over and over and over, thousands of times.
What's even cooler is that you can tell Delphos what you care about most. In one experiment, they gave it 3 competing goals. First, model fit. How well does it match the data? Second, parsimony. Is it simple and elegant? And third, plausibility. Does it actually make sense? You don't want a model that says people prefer longer commutes. And Delphos learned to balance all 3, finding models that were a perfect blend of accurate, simple, and sensible.
All right, so let's zoom out and look at the big picture here. This isn't just a clever bit of programming. This really feels like it could signal a totally new way of doing science.
So, when you boil it all down, we're talking about a massive shift in thinking. We're moving away from a static, brute force approach to a process that learns and adapts, just like a human expert would. Only this expert can run thousands of experiments in the time it takes us to grab a coffee. This tech is incredibly efficient, and it's driven by actual experience. Ultimately, it frees up human researchers to do what they do best: think creatively, ask bigger questions, and push the boundaries of knowledge, knowing they have this incredible AI apprentice to help them sort through the details.
And all this leaves us with a really fascinating and frankly kind of mind-blowing question for the future. Delphos learned the art of choice modeling. But this approach, this idea of teaching an AI to learn the process of discovery itself, that could be applied to countless other scientific challenges. So when we have AIs that can act as our research partners, learning and exploring alongside us, what other immense, unsolved puzzles are we going to tackle next?